questions in the chat. I will be responding accordingly. All right, so all right, let's go. So we're looking at some questions here. So this first question says, given that f of x is equal to negative 2x squared minus 12x minus 9. All right, so given that we have that, the question says express f of x in the form k plus a open bracket x plus h squared. So this is what we'd call the completing of the square. Believe it or not, there are many ways to approach this problem. So it's not like there is a one way to do this. So there are many ways to do this. I'm just going to do it one way in the interest of time. All right. So in the interest of time, I'm just going to handle this one way. And I'm expecting, so if you have a way that works for you already, that's fine. All right. That is fine. But definitely I will be working it quickly just using a formula. Right. So if I have this to represent, what I want to do is to write down my A, my B, and my C. So A is negative 2, B is negative 12, and C is negative 9. So having had these, basically when I'm completing the square, I'm just going to, I only need to find a value for H, which is B over 2A. And then after that, I find a value for K, which is 4AC minus B squared all over 4A. I also could represent this part another way. I can do that, right? So I can represent it another way. But definitely we'll get back the same answer. So I'm not going to focus on that. So again, making sure we have minus 2 for A, minus 12 for B, and minus 9 for C. So we have those. Now let's just substitute here to get H. All right, because H is what we're just going to plug right there. So H is B over 2A. B is negative 12 over 2 times A, and A is negative 2. So basically what we have here is negative 12 over negative 4. So definitely that is going to give us, at the end of the day, that is going to give me that H is a positive 3. All right, so I have my H value to be a positive 3 value. So I already have a part of everything that I'm about to do. Now let's go for the K value. In finding the K value here, I'm going to use 4AC minus B squared over 4A. So let's do the substitution. We have 4 times A is negative 2, times C is negative 9, minus B squared. So I'm going to put my negative 12 in a bracket squared all over 4 times A, and A is negative 2. So there it is. I have done my, my little substitution there quickly. So what I want to do now is to make sure that we work out these, try not to make any form of error, right? Working out these, try not to make any form of error. All right, I just left my calculator there. So I'm just taking out my calculator. Yeah, all right, let's go. So we're talking about 4 times negative 2 times negative 9. And we're getting 72 right there. So we're getting 72 here minus 144 all over negative 8. So 72 minus 144. That is 72, basically, yeah? So that's a negative 72 over a negative 8. And definitely we're seeing where we're getting a positive 9. So this K value is a 9. So basically what we're doing here, we're just applying a formula. You don't get this formula though. And there are other ways to do it, but I'm just going to just knock it one way. So here it is now. All I'm going to do is to write it in this form. The same form that they give, wherever. They asked us to put K out front. So they said write K there plus A here and X plus H all squared. That's how they asked us to represent this. And we are definitely going to represent it like that. My K value is 9, so I'm going to put 9 there. The A value is a negative 2, so I'm going to put minus 2 there. Open bracket, X, H is positive 3 square. and we're done. And so this is what they ask us to do. So whenever you're completing the square, whichever way you feel comfortable, I'm asking you to do it that way. There is no specific way that they will ask you. So your comfort comes first. All right. So this is our solution here in that form. Drop a comment. If you have anything to ask, you can ask. All right. All right. Good afternoon. Good afternoon, everybody. One more time. So there it is. We're looking at that. All right. All right. Let's look at the next question. Let's look at the next question. So the next question says, state the maximum value of f of x, the 1 mark question. It is important that we understand when we have completed the square, what and what we actually have, right? So I will say to us that, guess what? What we actually have here is the maximum value is that k value right there. So whenever I find my k value, it could be a maximum, it could be a minimum, because a quadratic only would have 1. So in this context, it's a maximum. So then the maximum value of the function is the k value, and it is a positive 9. So it's a 1 mark question. You're not required to do anything extraordinary to get it. So we are interpreting our thing. So f of x at maximum is 9, and we call it that 1 mark right there. We have 1 mark there, 1 mark there. Very good, very good, very good. So we don't need to solve. No, we don't need to solve this. Okay, all right. So we're working based on context of the question. All right. All right, let's go. Next question now. Hold on, guys. I'm looking at some comments. Make sure we have some comments there. All right, good. They said determine the value of x for which f of x is maximum. This is a 1 mark question again. Determine the value of x for which f of x is maximum. Now, when you complete the square, you know, as long as you understand the interpretation of it. Now, if we think about a curve, if I have a quadratic curve like that, right? Mark you. All right, let me let look a little bit better. If I have a quadratic curve like that, my maximum, let me just drop a maximum quickly here. All right, let's drop the maximum quickly here. All right, so I'm just going to drop my max line here. Just for clarity. Just for clarity, nothing big here. Just to show what's going on. So I would have my max right there. The only x value, so this is my max here, is a y value. This is my max, and it is a y value, right? The max is a y value. The only x value that is at max, right? The only x value that is at the max is our axis of symmetry, right? So if I go at the max here, there is going to be an axis of symmetry here. So my axis of symmetry, which is this, yeah, is the only x value at max or minimum. We need to make a note of that. Axis of symmetry is the only x value at the maximum or the minimum right here. Now, the thing is, it is x equal to negative h. So that is why when we complete the square, the interpretation of it would make everything simpler and easy. Because at this time, we're saying that, guess what? The axis of symmetry is actually the negative of h, but I have h to be 3. That means at this moment, my axis, yeah, of symmetry is going to equal to x equal to negative 3. At x equal to negative 3, we are at maximum because of this fact. So I'm going to put the fact here just on this, that the maximum point is negative h and a k. The negative h is my axis of symmetry and the k is my maximum in this context. So when we understand that, then everything actually becomes easy. So -3 would be the x value at the maximum. All right. Okay, Miss Forbes, I see you there. All right, let's look at this other question. Let's look at this other question now. The B part says, find the set of values of x for which 3 plus 5x minus 2x squared is less than or equal to 0. There are a number of approaches. I will talk. I don't want to spend too much time doing all the methods. But what are important is that whenever we get these inequalities with our quadratic, or what we call quadratic inequalities, what we're going to do is to try to find the critical values. And when we say critical values, I'm referring to you trying to solve it ordinarily. So when you try to solve it ordinarily, you would have gotten your x equals something. In this context, we don't have an equal sign, but the approach is the same. So we're going to approach it like that. And then we're going to, there are two ways we could do it. We could look at a sketch, because I know that this is going to be a maximum because my a value is negative. So because my a value is negative, I definitely know it's going to be a maximum. That means the sooner I get my two critical values, I will know how to sketch this. And from the sketch, we could discuss this part. There is another way, which is a little bit longer, where I will talk about it as we get there. So let us get the critical values first, right? So I'm pushing it to the side because I'm working here. So let's take off these from right here so that we could get some space to handle our business. All right, let's check this out. Now, we're going to factorize this, right? So let me write down my A, which is -2, my B, which is +5, and my C, which is 3, making sure that we're not making any mistake. So we're talking about A, B, and C. AC is equal to -2 times 3, which is equal to -6. I could run on and just get these stuff, but guess what? We're using 6 and 1 to get a 5 because my AC is a negative number there. All right, so I'm using the 6 and I'm going to use the 1, but guess what? I am going to have to use a -1 and a +5 so that I will make sure that, remember, the B is positive, so let the bigger one take the sign of B, and then we walk ourselves through this now. So we're going to walk ourselves through it right about now. So here it is now, AC. We're going to plug these in the middle there. So I'm just factorizing it. I'm not skipping any step so anybody feel kind of funny. All right. So it depends. If you want to rearrange it to suit yourself, that's fine. All right. You can rearrange it to let it look like how you want it to look. It does not matter. All right. So let us write down what we have. Let us say we have 3, and then I have +6x. I have -1x or -x minus 2x squared. And this is less than or equal to 0. Some people would do what they have to do to let this be positive, or it does not matter. All right, you're factorizing. So let us take out our 3 here. We're factorizing this, then we're going to factorize that. So if I take out 3 there, I get 1 plus 2x. That's fine. 1 plus 2x. So I'm going to take out -x for this part here, -x. So -x into itself is 1, and -x into -2x squared will give me +2x. This is still less than or equal to 0. Now, whenever I reach this stage and I realize that my 2 brackets would have come back, then I would feel very confident going forward because now I can refactorize, or for short, we would say that, guess what? We could easily write back one of these, yeah? And then put the other 2 things on the outside, here they are, in the other bracket. And we're still less than or equal to 0. So there it is. We have that, right? So we're looking at that idea right there. We're looking at that idea right there. So let us interpret this now. So this is saying that, guess what? All of these. So what we want to do though, is that we want to find the critical values. In finding the critical values, you are going to ignore this idea just for a little bit. Just ignore that because you want to just find the values that you're going to be using to evaluate your thing. All right. So then let's find them. So we want to say, guess what? 1 plus 2x is equal to 0. So we're getting at the critical values now. 3 minus x is equal to 0. So then we could see here, we have two things dealing with. From this one, we'll have x is equal to 3, 3 is equal to x. And then for this one, I'm looking at x is equal to -1 over 2. So then now I could utilize this in going forward, right? I could utilize that as I handle my business. So let us look at our business right now. Remember though, that we understand that this would make our curve having a maximum. So one of the ways in which you could do this is to put on your -1/2, put on your +3. So you'll understand that the curve would have gone somewhere because it's an idea. So the curve, let me put it in this color. It would have gone through a half, come up, and like that, right? So the curve would have gone through a half and come up like that. Because it has a maximum, so it's going to look like that. All right? So now, remember now, what we're looking for, though, is that we're looking for ideas where the curve is less than. So now we can focus back on our inequality. We are focusing on when this thing is less than, right? Less than 0. Now I'm going to just use a color code. So I'm going to drop a line. I could just continue my purple line going across like that. All right, so that line would have gone, that line would have gone, and we have a half right here, -1/2, +3. We're talking about less than or equal to 0, less than. So then I'll shade the idea for us. Would you agree that this area continue to infinity? The curve would have been under the 0 line, which means that it is less than. Also, if I come to the right of +3, the curve would have been less than, right? It would have been less than 0 because I'm going underneath the 0 line. Because everybody would have known that this is where y is 0. This line is where y is 0. So we're talking about looking at the yellow that I've shaded. We want to appreciate the fact that the curve is underneath the y equals 0 line there. And we need to represent that idea using our set notations, right? So we need to do that. So when you look at that, you would say that as I step to the left, when I step to the left of -1/2, when I step to the left of -1/2, I am in that region. In other words, these lines would have been touching the curve in the below 0. And when I step to the right of 3, those lines, x values would have touched the curve below. So we want to describe this. So guess what? Two quick description is that over here, it's like x is less than or equal to -1/2 because we're going that way to -infinity. And over here, we could say x is greater than or equal to +3. That means we're heading that way to +infinity. So basically, we need to combine the idea just to write like one complete thing. These two things are correct. You know, in themselves, the two responses are good, but we want to combine it by using a union because we want to unite all the values here along with all the values there to give the answer to the question. And what do I mean? Basically, I'm saying we're writing it in set notation. So we're saying that x is such that x is greater than or equal to 3. And that is like one little thing. So I could have a little, thing there. And we want to unite that with the fact that x, hold on, let me write this, sorry, with the fact that x is less than or equal to negative a half. You close it off. So we're looking for a set notation response like that, where we unite the idea, make sure it is in a curly bracket, because you're responding based on how they phrase the question. So let us peek back at the question and I'll come back. It says determine the values of x no, where am I? Find, my bad. We're reading this. Find the set of values, of x. Hence, we want to use set notation and represent it properly. So we use our curly bracket and all of that. All right. Again, if you just come, if you are not a person that have subscribed, I'm asking you just to subscribe to the channel and just hit the likes, everybody. Let's get some likes up there so that people who try to search for videos may find it a little bit quicker. All right. All right. Let us see if that is okay. I trust that everybody is okay with that question there. I hope that I did justice to that. I'm stopping just for a moment just to see if anybody is commenting on that. Is there any comment relating to what we're seeing? All right, it seems like everybody's okay with the response. All right, so there goes our response. There goes our response right there. All right, let's look at the other question. This is a 4-mark question we just looked at, 4-mark question. There's another way to do it, but in the interest of time, I don't want to. So Adrian, you could still test the regions if you're thinking it. Yes, you can test the regions and get the answer just the same. But if you can do a quick sketch, like you understand this, then you can just pull through as well. All right. The C part says a series is given by 0.2 plus 0.02 plus 0.002 plus 0.002 plus da da da. All right, so we're saying that we have a certain series and this is how it looks. We have 3 marks here. 3 marks here that we want to show, or we want to show that this is a geometric series. Now, it simply means then we would have to have some idea about a geometric series. All right, have some idea about a geometric series. Like, what do we know? Firstly, we know that a geometric series has what we call a common ratio. We call it R. Understand? So consecutive terms are produced by multiplying the previous term by R. We want to establish that. Let me say it one more time. We intend to establish the fact that consecutive terms, or the last term would have been a production of the previous times R. So there is what we call a common ratio between. So we want to show that there is a common ratio. And we want to look at something that we're going to point out here too, as it relates to the final analysis of, let us say, t to the n term. We want to show that, guess what? It is always a to the r minus 1. That concept. We want to use this to show that. All right. So we're going to show that right about now. We want to show that we can actually pull this off. Now, first thing that we want to do is to, you can line up these. I'm going to do it. I could do it to the right. Yeah. Or I could do it right there. Very good. All right. So I'm going to do it right there. All right. So we're looking at 0.2. We have 0.02. We have 0.002, and it goes on. What I'm going to do to prove is that, so this is 1, this is 2, this is 3. What I'm going to do is just to set it up so that we could see the common ratio. There's more than one way to prove the common ratio, all right? But I'm just going to prove it this way. So I'm going to say, guess what? If I have 0.02, divide by 0.2. All right. 0.02 divided by 0.2. I'll get 0.1. And this should be equal to 0.002 divided by 0.02. If there is a common ratio, I could say the second term divided by the first term should equal to the third term divided by the second term. And we do realize that when you do that, let me do it, even though I know what it is. I just love putting things on my calculator. Guys, I know it's a 0.1, but I love putting things on my calculator. So we're actually getting a 0.1. So both of them are saying, hello, this is 0.1, this is 0.1. So we're seeing a common ratio here. This is my R. We could represent the R as 1/10 if you want to look at it like that, because 0.1 is definitely a 1/10 as well. All right. Yes. All right. All right, guys, somebody's querying about the previous question. And in live, we have some little back and forth, and we don't want to leave anybody out. So definitely, I want to look at the questions. All right. It says, is the solution what was in the curve or outside the curve? It was the part that was below zero. And below zero would have been under the zero, outside in this context, the yellow area. So guys, let me show. It's just the yellow area, which was under the zero line because the curve was. So what we're saying is this part of the curve. And it goes on forever. So we are suggesting that it is these values out here that caused it. These values out here in the yellow region. So it's outside. All right. So I trust that you saw this now. And you're fine. It's the outside part we're referring to in this case, because it's below the zero line. And this is the y equals 0 line right here. This is the y equals 0 line. And we were looking at below that line. So I trust that you understand a little better. All right. All right. So R is 1/10, right? R is 1/10, R 0.1. That's fine. So we have that. All right. Our A is 0.2. Yeah. So we have A is 0.2 and we have R, which is that. I could show, we could, if we're looking at the ideas right now, you would see definitely, you know, that, guess what? Look at this. We started with A, and then the second term should say AR. The other term should say AR square. If I can show that this is happening now, then this is a geometric series. All right. So then we want to show that if I take up, if I have A, so term 1 is A. For term 2, it's going to be A times R. But we know what A is, right? So term 1, I'm putting it as 0.2. Term 2, we're proving it, you know. We want to look at something. So term 2 is going to be my 0.2 times my 1/10, right? And then we realize that we really got 0.02. All right, no problem. Term 3 is equal to what? 0.2 times. Remember, right now, this is going to be AR square, right? This one is AR and this one is A. So we're talking about AR square, AR square. So finally, it's 0.2 times 1/100 this time. And that is why I would have gotten 0.00. Hold on. 0.00. Let me push this across my screen. And we end up with 0.02. So you're seeing here that this is taking the form of a geometric series because we're looking at A, which is our first term, AR second term, AR square, and we're seeing that. So on this now, we could say that, oh, it is a geometric series because the t to the nth term can be found by saying A r to the n minus 1, because you're seeing where the third term, the ratio was squared. For the second term, the ratio was to the 1 power. And for the first term, there is no ratio there. So you could see this part coming out in the ratio as you go forward for the terms. So yes, this would have confirmed that it is a geometric series based on us just pulling those apart. Yeah, yes, Johnny. All right, guys, let's go again. All right. So this is good right there. That is good right there. So we identify the first term, identify the common ratio, and then show them that, look here, t to the n term is equal to a r to the n minus 1, because we were able to deduce that right there from that. All right. The last question says, find the sum to infinity. And they want us to give the answer as an exact, all right, fraction, because, all right, the sum to infinity will be given to you. This formula is given to you. So you don't have to try stress. They give you this formula. You will get the sum to infinity. So the sum to infinity, let me just write what the sum to infinity is equal to a over 1 minus r. When we're looking at when r is less than 1, it's set like this. But if r is greater than 1, you put the r in front under here. So in this case, r is less than 1, so it's at the back, all right? So we're using this to find the sum to infinity. We do have 0.2 for a at the top. Underneath here, we have 1 minus the common ratio, and the common ratio was a 0.1. I could work with a 0.1 there. 1/10 or 10 to the negative 1, or you could just say a 0.1, you know, to work easier. So we have a 0.2 over 0.9. And from this, if they ask me to do this, you know, guys, they were the ones who said, give me this as a fraction. I'm going to multiply the top and the bottom by 10 because I want to remove those decimals. So I'm multiplying the top and the bottom by 10 so that I will get 2/9 as an exact fraction, right? So remember, you know, 0.2 over 0.9 as a fraction is 2/9. All right, so you could see I here manipulate this by multiplying the numerator and the denominator by 10 in a response to this. If that weren't, if I never saw that, I would not stress myself. But because I got a specific thing to do, then I executed like that. All right, I trust that you're seeing that and you are okay with that. And that's a question. All right, so moving on to another question here. Moving on to another question. We're trying to put through as many things, no, that comes as possible. All right, remember to type any question that you have. I don't have a problem just going up back to re-explain, all right? All right, so what we have, it says determine the value of k such that the line, as I'm reading here, such that the line x plus 3y equal 6 and kx plus 2y equal 12 are perpendicular to each other. All right, they are perpendicular to each other. Now, in my judgment, based on what I understand of perpendicular lines, we focus on their gradient, right? Remember that when we have perpendicular lines, the product of their gradients would give -1, which means that one gradient is the negative reciprocal of the other gradient. So I am going to channel my energy there to use that to come out with a value for k. But here is the thing. Here is the thing. Here is the thing. It says determine the value of k. I am going to reproduce this in the form y equal to mx plus c. In that case, I'll be able to see the gradient because the gradient is going to be the coefficient of x every time. All right. So we're going there. We're going there right about now. So let us put this together. So let's focus on situation 1. X, let me say situation 1. I have x plus 3y equals 6. I'm transposing to make y the subject. I'm not stressing it. 6, so I have minus x plus 6. If I divide everything by 3, yeah, dividing everything by 3, then y is equal to negative 1/3 x plus 2. All right, so I have negative 1/3 x plus 2 right there. And that is one thing, because I'm going to focus on this when the time comes. That little piece of thing that I'm highlighting. Not the x or anything, just the negative 1/3. So that's my situation 1. Let us jump on situation 2 right about now. Let me change the marker for that. Situation 2, I'm having kx plus 2y equal 12. I'm still focusing on writing it in that format. All right. So it means then 2y is equal to negative kx plus 12. I'm going to divide both sides by 2. That k there is a constant. So basically, y is equal to, I could say, it's k over 2 x plus 6, right? So I have k over 2 x plus 6. All right. So not bad. K over 2 x plus 6. Remember the focus. In mathematics, we're not going to worry about things. The focus is the gradient. What relationship do we know about parallel lines? That one gradient is the negative reciprocal of 1. And in another realm, we could have said that when you multiply them, you should get negative 1. All right. So that means then that we're going to say negative 1/3 multiplied by negative k over 2 should give me negative 1. And I trust that everybody is seeing now the idea on which I am moving forward as I have this. All right. So negative 1/3 times negative k over 2, when they multiply, we should get negative 1, because we were told that we have perpendicular lines going on. Let us solve this ordinarily. No rush. All right. So basically then, I would have positive k over 6 equal to negative 1. Right? Therefore, so I multiply top by top, bottom by bottom, then I'm going to multiply both sides by 6. So definitely k is equal to negative 6. So I will conclude here that my k is negative 6 right there. K is negative 6. Anybody got that? K is negative 6. So we're looking at the fact that k is negative 6. Check in the comments. Yes, we're doing, these questions are based on what they put out that should be coming. Yes, Claudine. All right. All right, so we're looking at that. So k is negative 6. Now, the next question now is the equation of the circle. They will never leave off these. This question is there every single year. All right, now we're told that a circle of radius 5. All right, we were given the radius of the circle, guys. We were given the radius of the circle, and its center is the intersection of the two perpendicular lines. So now they're going to challenge us to do something, because now they're saying that, listen, they're giving us the radius for 3 marks. We got the radius already. And they're saying that, listen, the center. So if we find the center of the circle, we're good. But the center of the circle is where the two lines intersect. Remember though, I have this line already. And now I know what k is. So technically I have that. So let us just push this aside just a little bit for us to look on what's going on, right? All right, so because we know that the k is negative 6, all right, so I'm going to just take some spots here. I'm going to take off these little spots. All right, k is negative 6, all right? All right, so we could work. Here it is. Equation 1, x plus 3y is equal to 6. The next one now, I'm just going to write the k. So the k is negative 6, and then I have x plus 2y equal to 12. All right. So right there about, I am just handling that. what I'm going to do though, what I'm going to do here, I'm just going to multiply. So this is equation 1, equation 2. I'm going to multiply equation 1 by 6. All right, so this is mean. Remember, there are many ways to solve this. I don't want you to think that you have to do it this way. All right, I could solve this about 3-4 ways, but I'm just going to take it this way. I see where if I multiply equation 1 by 6, I get a 6 to eliminate this. So I'm going to try to eliminate this right now, and I'm just going to multiply the top equation by 6. So basically, let's see, 6 times x give me 6x. 6 times 3y will give me 18y, and 6 times 6 give me 36. All right? And then now, this, I'm just going to write back this here. So I have negative 6x plus 2y equal to 12. I'm going to add, because as you could see, I have a positive 6 and a negative 6. So if I add these two equations, some people draw the line, anything you want to do, you know. So if you should add these, if you should add what's going on, negative 6 plus 6 becomes 0. So I'm not going to write that. 18 plus 2y, 18y and 2y give me 20y. 36 and 12. This is going to give me about 48, right? So this is going to give me about 48. So 48, divide both sides by 20. Y is equal to 48 over 20. Make sure we're not making any error. Double check with me. Double check with me. I'm getting, hold on. I'm getting 2.4. I believe it is correct. I get 2.4. All right. I get 2.4 or 2 and 2/5. If you cancel down, you get 2 and 2/5. All right, so I get 2 and 2/5 for that. All right, so I hope you guys checking with me. 2 and 2/5. So that is what I got for the y. All right, or 2.4. Now I want to substitute this. I'm just going to substitute the value of y in equation 1. So equation 1 says x plus 3y equal to 6. So x plus 3 times y, and y is 5 to 2 times. This is like 12 over 5, right? 12 over 5. So that's 12 over 5. So you could see here, and this is equal to 6. So it depends on how well you work these things. So this is 36 over 5 equal to 6. I'm just going to write it out. All right. There are many ways to do it. I'm just writing it out. Don't crucify me. All right. All right. So this part is actually we could all right, let's multiply everything by 5. All right, let's multiply everything by 5 so that everybody could see what's going on. Multiply by 5, and you don't have to do it this way still, but I'm just saying. Then you subtract 36. Subtract 36. So 5x is equal to negative 6. Divide by 5. Divide by 5. So x is equal to negative 6 over 5. Or somebody might say negative 1 and 1/5, right? So if you want to say that, that's fine, all right? Nobody's going to crucify you with how you represent your thingy if you're not told to do a specific thing. This is the center of the circle. So the center of the circle, so we have some numbers here that are going to actually go to the center of the circle. I hope you are there with me. This is my y value here. And remember that when we go to the center of the circle, the signs that you have here will change, you know. So if I have a positive 2 and 2/5, it's going to be negative. Understand? If I have a negative, it's going to be positive. All right. So we're going to take them there and work them. So let us bring them to where the circle is. All right. So let me write them up top here. All right. So we have a negative. So I'm writing the solution for this. Negative 1 and 1/5, positive 2 and 2/5. This is the center of the circle. So believe you me, this is the center of the circle. But when you're ready to write it in the equation, things are going to just turn on you. All right, but it's the center of the circle. All right, let us see now how you're going to write it. All right, write the equation of the circle. They didn't give us a certain format, so I'm not going to overkill myself. I'm going to write it in the general form. So let's put it right here. Basically, guys, the circle says, all right, plus we have y. You could use different letters, and this is equal to r squared. I'm going to write it in that format. This negative is a part of the formula. So if a negative number comes here, it changes to positive. And if a positive number comes here, it changes to negative. And that's what I was saying. So now we have x, and then this value here is negative. So it's like we'll have a double negative. So you could just write the positive if you want. You don't have to overkill anything. So it becomes positive 1 1/5 square plus y. And then this value was a positive, so it's going to be a negative 2 2/5. And this is equal to 5 square. Remember, is r square comes here, which is 25 at the end of the day. All right, so at the end of the day, you just want to write 25 right there, r squared, which is 25. All right. So I'm just going to just write it out and just conclude. But I'm not going to break this into the other format because they never told me exactly that I have to do it a certain way. So I'm giving it to them and you will get your mark like that. So that's us writing the equation of the circle. I'm representing it in that format. Talk to me now. Are we good? I'm waiting on some response there. If anybody needs a re-explanation, definitely I'm going to do it. So we pull off the values, we got the values, and we write the equation of the circle here. That's the equation of the circle there, and I don't think any mistake is there. I think that is fine. Anybody dropping any comments? Anybody uncertain? All right, it seems like everybody is okay with what's going on right there, right? Remember to ask your questions as we go. All right, just remember to ask your questions as we go. All right, so that's that. Let's go to the next question. So yes, vectors are coming, right? Vectors are coming. All right, so this question says, all right, let's look at it. We have to read it. Let's clear this up. All right, so this question says, RTS is a straight line in a coordinate plane. So we have, oh, RTS is a triangle. I did say straight line, I apologize. RTS is a triangle in a coordinate plane. Position vectors R, S, and T relative to an origin O are as follows. So RST. So basically this is OR. I'm just going to write it. This is OS. I'm going to write it. And this is OT. So I'm just putting it there so that when we're ready to do some work, we have the frame to do the work. So we have OR, OS, and OT right there being given. All right. The first question says, show that angle TRS is 90 degrees. All right. So talking about angle TRS is 90 degrees. You need to have a visual. It's good to have a visual of the situation so you know what you're about. So let me push this to the side. We want to show TRS is 90. Let me blow this up right there. TRS is 90. So TRS, I want to show that TRS is 90 degrees. Some people might be writing the question, but it's on 9. All right, so we could go back to that. TRS is 90. Now, so I'm going to just work this. TRS is 90. So I'm just going to close up this, right? So basically, I'm saying TRS. Show that TRS is 90. If I'm going to show TRS is 90, definitely you're seeing that I need to have TR and I need to have RS. So if I have TR and RS, the angle is between TR and RS. So therefore, I could use the concept that the dot product of two vectors, if the dot product of two vectors is 0, then the angle between them is 90. So if I'm being asked to show that the angle between TRS is 90, I'm going to go for a TR and I'm going to go for RS. And then I am going to show that the angle between them by using the dot product rule. The dot product should be 0. That's the concept that I'm going to embark on. However, I need to find TR and I need to find RS first. So let's go for those. So that's just a quick disclaimer of where we're going. All right. Okay. All right. Claudine, I'm not sure what you're saying there, yeah? All right. Let's look at TR. All right, so if I'm going to do TR, then I want to move from, based on what I have here, I'll move from T to O, and then move from O to R. All right? T to O and O to R. So basically then TO, we have OT, so we're going the inverse, so we're going to take the opposite directions, all right? All right? So we're taking the opposite direction. So let us look at it, making sure that everything is okay. So we have 4, 4, so we're going -4, because we're going in the opposite direction. And then OR is 1, 1. Yeah, let me just add 1, 1 to that. This is equal to -3, -3. All right. So that's -3, -3 right there. All right. So we have that. So that is TR. Let's go for RS. If we're going for RS, then we could move from R to O and then O to S, and we get RS. So RO is -1, -1, because we're going against OR, opposite direction, because we got OR from the system. OS is okay. OS is okay. So we're moving in that regular OS. All right. So this is giving me 2, -2. All right. So I get 2, -2 there. All right. Now, you see, if what we're saying, you know, if there's a 90-degree between these two vectors, because now you have seen that we have found RS, we have found TR, this is RS, yeah, and this is TR. And what we're saying is if there's a 90-degree between them, the dot product of them should be equal to 0. So let us prove that now, right? So the dot product of, so we want to prove the dot product of this. Dot product of TR dot RS, all right? TR dot RS. Now, remember though, TR is -3, -3, right? And RS is -2, +2, -2. So let me write them down so that we could look at what we're about to do, right? These are the two things. We're going to multiply these here. So we're going to multiply the two x's from the two different vectors, and we're going to multiply the two y values, and then you add them. And if you get 0, there is a 90-degree between them. So here it is. We're looking at -3 times 2 plus -3 times -2, -6 plus 6. And this is 0. And the fact that we got 0, it means that there is a 90-degree between the two vectors. All right, there's a 90-degree between the two vectors. All right, so there is that. So yes, there is a 90-degree between them because we have just proven that using the dot product. The dot product is simply taking the x values of the two vectors, multiply them, taking the y values of the two vectors you're proving, multiply them and add them. All right, so that's the dot product overall. Whenever our dot product being 0, then it means that the angle between the two vectors is 90 degrees. You can always do that to prove that. So we have proven that just now based on what went on. So we're good. The next question is asking us to find the length of the hypotenuse. All right, so finding the length of the hypotenuse. Basically, if you're going to find the length of the hypotenuse, there are two things that you could do. You could use these two vectors to find TS and then find the magnitudes of TS, or you could use Pythagoras theory. But I'm just thinking, why not just find TS and find the magnitude of TS and finish? So I'm going to take that route. Understand? Because I could find TR, the length of TR, then I could find the length of RS, and then use Pythagoras theory to get the length of TS. But I don't want to do so much work because I'm thinking that it is very simple to say, I could move from T to R and R to S, and I get that, the components for TS, and then I just deal with it by itself. So there are more than one ways to get these. I am not here to say that you have to do it this way. You work the maths according to how you're comfortable. But I'm going to arrive at the same answer right about now. So I'm going to take, I'm going to travel from T to S. Because vector is about traveling. I am going to travel from T to S and do it. So I'm going from T to S. TS is to move from T to R, plus move from R and end up at S. Now, T to S. Remember now, T to R, we have TR. TR was -3, -3. RS, I have RS as 2, -2. Now, when I add these together, I'll get -1, -5. I want everybody to work with me. I get -1, -5 for that, all right? So you double check that for me, -1, -5. All right, that looks like the root of 26 right there, all right? So then I'm going to work out that now. So the magnitude of the hypotenuse, which is TS, magnitude of the hypotenuse, which is TS, is going to equal to the root of -1 square plus -5 square, right? And then we are looking at the root of 26. So, and this is finished. You don't need to break this down. Root of 26 units and we're done. So that's not the only way you could have approached a problem. I'm just saying that because it's vectors and I could just walk, I just walk for the hypotenuse and then find the magnitude of it, rather than finding about 3 magnitudes and then work out something again. I just walk and then I do it. All right. All right, let's move, let's move, let's move. So we have looked at that. All right, so we're looking at this question that says the equation of the curve is y equal to 3 plus 4x minus x squared. The point P, which is 3, 6, lies on the curve. Find the equation of the tangent of the curve at P and give your answer in that format, ax plus by plus c. All right. What we're going to do here, though, is that, think about this. We're told that the equation, right? We're told that the equation of a curve is this. So we have the equation of the curve, no problem. The point is on this curve. So there's a point on this curve. So this curve looks like that. And then there's a point on that curve. We call that P. And then they're saying that this is 3, 6, right? It lies on it. Find the equation of the tangent. So all I want to do is to find that tangent line the equation of that tangent line right there, all right, to that curve. Remember though, all I'm going to do, is to use calculus to find gradient function, because gradient is the boss of calculus, all right? So I'm going to find the gradient function. And when I do find that, what I'm going to do is to plug in 3 in the gradient function to find the gradient at that point P. Now, if I know the gradient of that point P, all I have to do is to use that gradient on the same point P, and I'll get the equation of the tangent at P. Let me go again. Gradient function, plug in the 3 to find the value for the gradient at that point P. So let's go by taking our derivative now, right? So we want to take, let's write this first. Y is equal to, let me push it across a little bit, or I need to write to the right. Hold on. I think I write better over this side. All right, good. So let us say we have y is equal to 3 plus 4x minus x squared. All right. Now, we are told what happened. All right, there's a point on that, no problem. So dy dx is going to equal to 4 minus 2x, right? So dy dx would have given me 4 minus px. What is this? This is my gradient function. And it means then at any given point on that curve, I could plug in any x value to get the gradient of the curve at that point. I am able to get that. So then, because the point that we're dealing with is P, which is 3, 6, yeah? The 3 is the important thing for me right now. So let me make sure that there's a 3, 3, 6, good. We are going to substitute 3 there. So the value, right, at P, so the gradient, let me write it, at P, which is 3, 6, is equal to 4 minus 2 times 3, which is equal to 4 minus 6, which is equal to minus 2. So the gradient at P is minus 2. Now let's think about this. A tangent is going to pass through at this exact point. Because a tangent is the concept of a tangent is that it kisses the line and it moves. All right? So it does not cut through. It kisses it at a point, and the point is going to be right here. So what we're going to do now is to use the gradient. So m is equal to -2, and the point P is 3, 6. And I'm going to create the equation here. So the tangents, right? The equation of this tangent, we're going to derive it from here. Multiple ways of doing it. So I won't tell you how to do it, but I'm just going to do it one way. All right, so I could just find C and then write it. So using y is equal to mx plus c, all right, using y is equal to mx plus c, I could just find c and then we sort out the problem. So substituting x and y here, 6 is equal to -2 times 3 plus c. So make sure that there is no error. So we have to look, make sure that there is no error, right? So we're talking about 6 is equal to -2 times 3 plus c. 6 is equal to -6 plus c. Adding 6 to both sides to balance out, 12 is equal to c. Now, I could now write this, but it's not in the form that they want. All right, so this is -2x plus 12. But this is not the form that they had asked us for. They want us to write it like this. So everything is going to come across and is equal to 0. That's fine. All right. So then this -2x will be +2x. This is a positive y, and this is a -12. And this is equal to 0. And we would have written it like that. All right. All right. So that is, I hope everybody see that and you're fine. with that. And remember, you can get there other ways. So it's fine. Get there. Those are the values that you should be looking at, though. Those are the values that you should be looking at if you get there. All right, let us, let's continue. Let's continue. So that is the gradient of the tangent that passed through the point P. Now they're going to ask about stationary point here. So this one says, given that f of x is equal to, I'm reading here. I'm reading right here. So it says, given that f of x is equal to 2x to the third minus 9x squared minus 2x plus 7. All right, so given that f of x is equal to that. All right, somebody asked a question, guys. Let me pause. All right. All right. Somebody want us to read you the calculus part. All right. So the calculus part, all right. When you say the calculus part, I believe you're talking about the derivative. So let me just quickly type. Respond to me as quickly as you could see. All right, the person who asked about the calculus, I assume you're referring to where we did the dy dx. All right. All right. Why we do this? So guys, give me a minute. Let me just respond to this person. Whenever they ask about gradient, I could tell you that, remember that derivative is the gradient, is your gradient function. So if you're differentiating, when you differentiate is gradient, you're finding a function that can help you to find the gradient at any point on the graph. That's what you actually find. It's just that sometimes when we do derivative, it's just done as a rule, and people don't really go in depth to know that, listen, you have found a function for the gradient. That means you could punch in any x value and it's going to tell you the gradient at that specific point. Now, having that knowledge, when I see this question, when I saw it, I'm saying, okay, we can write the equation to the tangent because we are able to get the gradient at that instant. So we are able to use the gradient function and find the gradient where x is equal to 3. And if I have the gradient at a point, I could write the equation of a line. So then we decided that we have to take the gradient of this, right? All right. So take the gradient of this. No, that's, I'm not going to do it without calculus because that's why you learn calculus here. You learn it to do it, to use it. All right. Yeah, man. So I'm not going to do that now because as I said to you, it's a skill that you need to have. So you just take your derivative and know that it is the gradient function, plug in the values and you go. That's what you're expected to do in a basic syllabus, honestly speaking. So if you get a question like this, please don't try to do anything else. Take your, like this, don't try to do it any other way. Find your gradient function, which is the derivative, and then find the gradient at the point and then use it back. That's why you learn calculus in AdMaths to use when the time comes. So I'm not going to try to do it any other way, no, because I really want you to do it this way because this is what you're supposed to be doing here in AdMaths. All right. So let's go with this one. It says, given that f of x is equal to 2x cubed minus 9x squared minus 24x plus 7, stationary point. What do we mean by stationary point? Again, this is when the differentiation come again. Stationary point is referring to a point on your graph when your derivative, which is the gradient function, is equal to 0. It simply means that you're going to have to find dy dx and let it equal to 0. Now, at this point, the curve is stationary, meaning it's not moving. What do I mean? At every, let us say the curve looks like this. At every step of the way, this curve is either increasing or decreasing. The curve is either increasing or decreasing, but there are some specific places that it is neither increasing or decreasing, and it is called stationary point. So this is one, and that's another. I'm just giving ideas. So the moment you step to the right or to the left of your stationary points, you are either increasing or decreasing. I am saying we're going to take the derivative of this function. We're going to let it equal to 0. That means we're going to be coming right at this point here and that point there. So when we take the derivative and let it equal to 0, we're going to be finding the x values here and there. Now, after you have found the x values there, we're going to substitute those x values back in the original to get the x and the y, which would be a point. You understand? That's how the point comes in. A point is an x and a y value. We're going to do it. So that's the route that we are going to take right about now. So let's go for our derivative. So let's shift this a little bit to the side to grab the derivative right there. Right. All right, Parry. Exactly. That is what we're saying. When our derivative is 0, right there. So let us go for it now. Let me just write this quickly. All right, hold on. I'm grabbing my pen. All right, so let's say the f of x is equal to, we have 2x to the third minus 9x squared minus 24x plus 7. And I'm going to take the derivative. So I'm using that little notation. So the derivative now is going to be, work with me, 326x squared, subtract 1 from the power, minus 18x minus 24. This is my derivative right there. Now I have my derivative. I want to understand that at stationary point, my derivative is 0. So now I'm going to have to say 6x squared minus 18x minus 24 is equal to 0. I'm trying to find the values when my thing is stationary. So stationary means that your gradient is 0. Please remember that. So gradient is 0 here. But guys, these numbers are nice. So I'm going to divide all of this by 6. You can manipulate the thing to get smaller numbers to work with. It's fine. It's the same answer. So if I divide through by 6, this becomes x squared minus 3x minus 4 equals 0. Same math, but I'm now working in a simpler form. So I could just set up my two things and go right now, right? So I'm working in a simpler form so that at this moment I could say, oh, but I can actually just look at this and I have an x plus 1, and then it's going to be a x minus, hold on, minus 4. Huh? X minus 1, x plus 1, x minus 4 equals 0. Right? So when we factorize this little thing here, we're going to end up with x plus 1 into x minus 4, right? So now, having that, now we could find out that, okay, so watch this now. So we're getting our thing. So talking about x plus 1 is equal to 0, which means that x is equal to negative 1, x minus 4 equal to 0, which means that x is equal to 4. Now, here is the thing. So these are the x values at my critical, what we call the stationary point. All right, these are the x values at the stationary point. No, this is not the answer to the question because I need to find the y values now. So I'm going to have to go back and evaluate f of negative 1 and evaluate f of 4, getting the respective y values. And then I would have submitted those points at the stationary. So let us know where are the things. Hold on, just give me a minute. Don't want to error because you can make errors easily. All right, I'm going to evaluate. So let me say this then, that when x is equal to negative 1, I want to evaluate to find the y. So I'm going to do f of 1. So f of negative 1, which is going to equal to 2, open bracket, negative 1 to the third, minus 9, open bracket, negative 1 squared, minus 24 times negative 1 plus 7. I am getting my y value now that matches at the stationary point with negative 1, right? So we want to take our time and we'll work this out. This is going to give me negative 2. Work with me, guys. This is going to -2, -9, +24, +7. All right. Put all of that together. I'm looking at, this is 20. This looks like 20. This is 11, -4. Yeah, this is 20. This is 20. You know what that means? This means that one of my stationary points is -1, 20. Stationary point 1. Stationary point number 1. Just that everybody would have seen the concept here. Evaluating that, blah, 20 works with that. That's the idea. So we are at stationary point 1. All right. All right. -1. Remember, it's -1, you know, Jonathan. Remember, it's -1. Double check it for me. It's -1, Jonathan. All right, let's go for the next one, please. We could go for the next one. So we're going to go stationary point 2. So stationary point 2. Stationary point 2. Stationary point 2. We're going to evaluate f of 4. We're going to evaluate f of 4. F of 4. We're going to evaluate f of 4. So f of 4, we're going to have, work with me now, it's going to be 2 open bracket 4 to the third minus 9 open bracket 4 square minus 24 open bracket 4, and then there's a plus 7. So I am evaluating them. So you're good? You're good? Evaluating that. So this is going to give me 4 times 4 times 4, 64, 64 times 2, 128, 4, 4, 16, 16 times 9, 16 and 9, 144. Where am I now? -24 times 4, 98, 96. I think this is about 96. Work with me. Plus 7. All right. So those numbers look okay. Double check with me. I'm getting a big number here, -105. And I believe it is correct. So the stationary point now is, the other stationary point is 4 with -105. And I'm telling you, that's the approach for them. That's the approach. All right. All right, all right, all right. Okay. Oh, okay, 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 okay. Okay, Jonathan, I get you, I get you, I get you, I get you. Yes, 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 exactly. All right. So we have this, we have those points. I hope that everybody understood what went on there. Those are the answers now for that. Let me see how much marks I give you for that. A whole lot of marks. That's why we work this hard. Look at this. So what we're saying, you know, is like we would have had -1 with 20 here. I'm just saying, this is just a makeup thing. And we have 4 with 105 here, with -105 here. That's what we're saying. So we're saying that, you know, this is the idea. That's the idea. Let's go for more. Let's go again. All right. All right. -105. All right. All right. So let's go to the next one. So we have -1 with 20 and then +4 with -105. All right. And there we go with that. All right. Let's look at this now. This now we're dealing with some integration. Integration there, right here. So we have to evaluate the definite integral of x into x squared minus 2 dx from moving from 2 to 4. Remember though, at this level in ADMATH, you will get mainly polynomial and some sine and cosine to deal with, whether they're going to ask you to differentiate or to integrate. All right. And so like this one, just multiply here. You're going to distribute the x inside and then get your polynomial and then deal with your integration. All right. And then work out your interval. All right. Let me rewrite this a little bit to the right, up top, like about here. So the integral of, so we're going from 2 to 4. And we have x into x minus x squared minus 2, and we have dx. That's where we are. All right. let me shift this now. Let me shift this. So we're evaluating this. All right, so what I want to do is to show that this is the same thing as, so I'm going to distribute the x inside. So I'm having x to the third minus 2x dx. So there it is. I am actually saying that this is what I'm going to integrate. Right, based on what is going on, I'm finding the integral of that. All right, so let us just go ahead and do it. Finding the integral of that. So the moment we start to integrate, we're going to have to put in our stuff. So integration, we're going to add 1 to the power and divide by the new power. So this becomes x to the 4th over 4 minus 2x squared over 2. All right. But definitely you're going to see where you're going to have some canceling going on, because this is definitely going to cancel. All right. So we're moving from 2 to 4. All right. So we have, so this is equal to, let me just write back this nicely, x to the 4th over 4 minus x squared, and we're moving from 2 to 4. So that is what we're going to integrate right now. We're going to find the value of right now. So definitely we're going to just put this out front here. So we have, let me put it in my bracket still. So I'm going to move from, so the bigger one goes out front. So we're going to have 4 raised to the 4 over 4. So that's like 4 to the third. So that looked like about 64 to me already. Minus 4 square. Yeah. And then this we're going to subtract. We're going to subtract this idea. 2 to the 4th over 4 minus 2 squared. So that's the setup that we have. So let's find our values now. Let's find our values and we're done. Find our values and we're done. This gives me 4 to the third. This is about 64. And then 64 minus 16 is in the front piece. Minus 16 divided by, this is 4 minus 4. This is a 0. All right, that's a 4 minus a 4. That's a 0 that I get there. All right, so this is 48. 48 minus 0 is 48, guys. So the answer is 48 for the definite integral. So I hope you are okay with that. Ask any question that you have to ask. All right. All right, good. All right, let me look if I can find somebody's asking for a specific thing. All right, so I'm going to jump. Oh, we have time. Let me finish this and then I go straight to somebody asks a kinematics question. I think one is here. So let me just finish this first and then go there. All right, so I'm going to finish this piece and skip, but all of these are important to know. So this piece, and this is different. All the questions are different to know. Every single one of them is actually different. All right, I feel like I want to do this one. And then I could go to a kinematics and come back up. All right, because somebody just wrote that they want to see if even one kinematics question. So I'm just going to do this and then we go up there. So let me come over this side. All right. Leaving your answer in third. Oh, we're going to leave our answer in third. I think this one is a nice one that we need to try, man. All right. All right, so we're still integrating, but they want the answer to be left a certain way, which means that we're going to have to come up with some stuff. All right, we have to come up with some stuff. So let us go quickly here. All right, so we're looking at, where is it? We're evaluating from 0 to pi over 3. Pi over 3 is like 60 degrees, guys. So if you want to be thinking like that, that's a 60 degree there. So more like it is 60-30 triangle. We're going to use it to get some values easily out, you know. All right, plus 2 sine x, yeah, and close the bracket dx. We want to integrate that. All right, we want to integrate that. Remember though, with the trig function, when you differentiate cos, you get negative sign, and when you differentiate sine, you get cos. So remember, all we have to do is to think backwards, right? We're going to think backwards. Remember that when we're taking the integrals, we actually could pull certain things out quickly. I mean, you're just doing them piece by piece, right? So if we're doing these piece by piece, then we're taking the integral of, so we could write the answers no. All right, we're taking the integral of this. Because look at the angle, there's nothing in there. So that means we don't have to worry about any movements, right? So where is this coming from? This is coming from 4 sine. So this is like 4 sine x. You know, think backwards. So in other words, then when I write this here, think about the differential of this and see if you get back that. And think like that, because they're not going to go deeper than this for these at this level for you. All right. So we have a 4 sine of x plus, and then this one now is like you're saying, remember though, the derivative of cos is a negative sign, but this is a positive. That means this would have to be a negative cos coming out. So we have 2, but this was a negative cos that actually did that. Because the negative and the negative would have made that a positive up there, coming there. So you're thinking reverse. You have to be thinking like that. So we could finalize our thing. We're moving from 0 to pi over 3. Let us just rewrite this quickly. So if I rewrite this, finally, I will be dealing with this. I'm going to have the negative 2, and then I have cos x. And I'm moving from 0 to pi over 3. Right? So that's what we're going to be dealing with there. And we have to be careful with the zeros. Remember, we can't just think the 0 is going to be 0, it depending, right? All right. No, it wouldn't be negative sign. The sign is positive. The sign is positive, right? Remember, is integral we're doing. It's not differentiating, we're differentiating. So the person who asked me about this, if we were differentiating, it would have been a negative, but we are not. We are doing the backwards or the reverse of differentiation. Remember, this is integration. So you have to think, where was this coming from? All right. So please be mindful of that. All right. Be mindful of that. Somebody who named gaming, I'm not sure. So it's the integral you're taking. So it's the opposite thinking you're going to have now, please. All right. All right. So let us look quickly at this. All right. So what we're going to do though, is that we're going to put the limits in this easily. But you want to know some stuff. So quickly, I could just let you look at this just to get some values out, because this is a 60. So I'm talking the 60, 30, because the moment I have 60, I have 30. We have 1 and we have 2 and we have the root of 3. This is what we're going to use to plug in here to respond to these questions. These are the numbers that will be coming out, root 2, 3, because we are in the 60, 30, because pi over 3 is equivalent to a 60 degrees, all right? So we want to understand that, all right? So we have pi over 3, we have pi over 6, which is 30. So it's this triangle that they're dealing with there. So basically, they said they want the answers in thirds. That means they don't want to just put in the calculator and give some value, all right? So let us sort out this stuff now. Let me move this. So we're talking about putting in this value here. 4 sine, and we're putting in the bigger one, which is pi over 3 here. And we soon look at what pi over 3 is. This is pi over 3. All right, I just wanted to know that that is pi over 3, 60 degrees. So we can work from there. Minus 2 cos of that same angle here. All right, so we're going to put it pi over 3. All right, pi over 3. Let me just put some little bracket around them, you know. All right, so that is that part. Minus now, we're going to have 4 sine. And then we have zeros in these, 0 minus 2 cos 0, and we'll close it off. Let me remove this from right here. All right, so it looks a little better. And let me just shade this for us so that we saw what we're dealing with here. All right, good. Now from this, we're going to have 4 sine of this. And this is root 3 over 2. Look at it, sine of this. Remember, I just told you that 60 degrees is pi over 3. So opposite over hypotenuse. So they want us 2. Let me move the sign now. I'm going to put the value there, guys. So when we talk about sine of root 3 over 2, sine of pi over 3 is root 3 over 2 will be multiplied by this. That's the value that you get for that. That's all I'm saying. Then we have minus 2. Cos of the same angle is 1 over 2. So we times that by 1 over 2 right there. That's our front piece of action right there. For the last piece of action though, I am looking at, remember now, 4 sine of 0. Sine of 0 is 0. You know? Sine of 0 is 0. So it's like you have 4, 0 minus 2. Cos of 0 is not 0. Cos of 0 is a 1, right? Cos of 0 will give you 1. So you'll have a 1 there. So be careful. Don't think everything is a 0 around there. That's a negative 2 we're mingling with. So let us see the final response. Here, what we have. I could cancel this. I would want to, let me use another marker. I would cancel this. So this is like 2 root 3. Oh, I could cancel this as well. So, all right, let me write this. I have 2 root 3 minus 1. And then I actually have, let me just do this now. Minus for this, and then a minus in there again. All right. So I could just fix this up. 2 root 3 minus minus give us a plus. So this is a plus 1. Right. So that's the answer inserts because this is it. Meaning we did not try to find the root of 3, and so we leave it like that. So I'm just saying, just be careful, work your thing. I think this question is nice. I like it. Kind of take you out of the norm. I hope you're okay with that. All right, somebody's asking us to repeat the first section. All right. I'm not sure what you mean by the first section, but I'm just going to just talk about this through. All right. I believe you are referring to here. When you're going to take the integral, remember, let me just say it, because a lot of times people tend to mix up integral with differentiation. So remember, where do I write this? Yeah, I can write it right there. They will give you this formula. They will tell you that d dx of cos theta give you negative sine theta. They give you this in the formula sheet. They will tell you again that d dx of sine x equal cos x. We are not doing d dx. We are doing the reverse of the d dx. So that is why I was saying to you, think in reverse, because we're doing the integral. The trig functions, one has to offhand know the differential of cos is minus sine, and the differential of sine is cos. You get this from them in the formula sheet section. Now, if you have the integral, which is the reverse, so you're saying that what you're asking yourself is, what was there before the derivative was taken? So you're saying, oh, okay, it must be sine, because you're thinking. So in other words, then, if you think that you're doing the derivative of this part, you should get that part. That's what we're saying. If you're doing the derivative of here, you should get that part. That's the thinking you want to have, because it's trig, you know. So it's not like you're not going to figure out. You're going to have to remember this, that this is the derivative of that, and you go backwards, going backwards. So if I saw the integral of a cos, I know that, oh, that means the differential was a sine. So I connect that already. But if I see this and I'm saying, but the differential of something give me a positive sign, oh, but cos would have given me a negative sign. But if I have negative cos, it gives me a positive sign. So that is why we did this and understand it. All right. So that is what I'm saying right there. I trust that you kind of pick up back what I was saying there. Remember that you're doing the integral now, not the derivative. So you have to go opposite to what you know from the derivative coming forward. So gaming, I trust that shed a little bit of light on your thinking. All right. I'm going to go for a kinematics question, or because somebody asked for it. So I'm going to jump here. I'm going to jump the C part, and I'm going to go, I think I have a kinematics somewhere. I have statistics, probability. Here's a probability question. I wanted to do it. But, all right, let's go for All right, I hope the question is down there. Ah, here it is. Here is our kinematics. I don't have a lot of them right now because I just put one piece of every little thing that we're expecting. All right, so it says a particle started from rest. We have to take note of this. A particle started from rest. This is important. All right, a particle started from rest in a straight line with acceleration a, given by a is equal to t squared, where t is the time in second. All right, particles start from rest. If the particles start from rest, t is 0, the time is 0, everything is 0. You understand? Velocity is 0, time is 0, acceleration is, everything is 0 at that point, right? So the particles start from rest, everything is 0. Now, the question says, determine the velocity. We have to know that here is a quick principle. There are 3 things in context. 1, we have S, which stands for displacement. Notice I'm not even saying distance. So we have displacement because it's distance moving a specified direction. So that is why the specified direction turned it into a vector quantity, which would have made it velocity and not speed. So it's linking to velocity. Then now we have velocity that comes out of this, and then acceleration that comes out of the velocity. So here's the whole thing. If I differentiate displacement, I end up with velocity. Because when I differentiate, I'm going to differentiate displacement with time. You understand? So I'm going to have ds dt. ds dt gives velocity, because this is displacement over time. Now, if I do dv dt, I am dealing with velocity changing with time. I get acceleration. So then you could see that if I integrate acceleration, I get velocity. And if I integrate velocity, I get displacement. So think about coming forward and then going backwards. So you differentiate to change the gear, moving from displacement to velocity to acceleration. There's all this, just taking derivative. But if any at all I'm going backwards, I'm going to have to do the reverse of derivative, which is to take the integral, take the integral, take the integral. So that is the disclaimer before we actually work this sort of problem. So let me clear the board now, understand, to approach this problem. So it's not really a big of a deal. You're just gonna remember that. Determine the velocity v of the particle in terms of the time t, all right? Velocity, as I just said, velocity is equal to the integral of acceleration. And we're gonna have dt, all right? That is velocity. But I was just told, all right, so velocity now is gonna equal to the integral of, I just told that acceleration is t squared. So it is t squared dt. So if I integrate my acceleration function, it's going to take me back to velocity, and that is what they expect you to do right there. Now, how do you integrate? Velocity now is going to equal to t to the third over t. We're adding 1 to the power and dividing by it, plus the constant c. But we are going to find out though, because you see, this problem started from rest, which means that at rest, my velocity is 0 and my time is 0. So then I want to know my c. Having had this, I'm going to say I need to find c. So velocity is equal to t to the third power over 3 plus c. Remember now, v is 0, yeah? Let me write that better for us, please. 1 second. Hold on, let me re-explain. V is 0 and t is 0 because the particles start from rest and rest not moving. So 0 is equal to t, which is 0 to the third over 3 plus c. 0 is equal to c. Now, if my c is equal to 0, I could definitely say velocity is straight up t squared over 3. I don't have to worry about the plus c anymore because the constant is a 0. So I am very confident just to write my straight up velocity is equal to t to the third over 3. I trust that that would have made some sense to you. Trust that that would have made some sense to you right there. Who asked for the kinematics? That's Harrison. You asked for some kinematics. I trust that that was kind of clear to you right there. All right, so that is our velocity function. They didn't ask us to find anything. We represented it in terms of t. All right, calculate the displacement s of the particle in the interval from 0 to 2. All right, no problem. In order for me to approach this problem, I would have to find a function for displacement, which means that I'm going to go again. Because remember, I said, you know, when you differentiate and go forward, you integrate to come backwards. So then I could start by saying, guess what? My distance, which my displacement should say, displacement. All right, guys, I'm asking everybody to hit the likes, please, hit the likes. And if you have not subscribed to the channel, please do so. Thank you. All right, so we're saying the displacement is equal to the integral of velocity, dt. Now, we have a function for that. So the displacement is equal to t to the third over 3. And then we're going to do this with time. Yeah, dt. There it is. So now, the moment we're going to take the integral, we're going to now say this function is equal to what? Let me not even write the bracket. Because yeah, I could do the margin after, but let me just find the function now. We're talking about adding 1 to this, so 4 over 4 plus c. Now, again, I need to know that constant before I do anything. So I'm going to drop in some values because a particle starts from rest. That means s is 0 and time is 0. I'm not even taking it for granted. I'm doing it every time. Even though I know it is 0, I'm still doing it. So I'm saying that 0 is equal to 0 to the 4th over 4 plus c. And you are seeing that c is 0, which means that I could confidently now write my displacement function by saying my displacement function is equal to t to the 4th over 4. I don't have to put no plus c. C is 0 right now. This is my displacement as is. All right, so that's my displacement right there. Now they want us to tell, they said calculate the displacement s of a particle in this interval. We're moving from 0 to 2. So now we're going to move from 0 to 2. I'm moving this from 0 to 2, which means I'll have 2 to the 4th over 4 minus 0 to the 4th over, my bad. Yeah, 0 to the 4th over 4. And then we end up with 16 over 4. 16 over 4 minus 0. So 0 is at the back. So I do get 4. Look if I made any error there. So I'm getting 4. Look if there's any error that was made right there, because sometimes it makes some little error and you don't know. So let's double check it for me. Double check it for me to see if I made any error there. Anybody? Check it. All right, so I'm looking. All right. I'm looking if I'm making it. Hold on. Ah, yeah, there's an error there, guys. Guys, there's an error there because I'm looking back and I'm saying, I feel like I made an error right here. So there was an error here, so I'm going to fix it. There was an error right here. We should have 12 here because when the 4 comes down, the 3 was already there. So the 4 is going to come down. Yeah, there was an error right here. And that's fine. That's fine because every now and then you make errors. I make errors as well. I'm fine with that. Right here. Right here, there was an error made right here. So let me fix it. Right here. Hold on. Right here. When we started doing this, we're going to take t to the 4th. There was a 3 there. And then the 4 is going to come under here. Yeah, because I was saying kind of look weird. So it is that over 12. So that's my error there. Plus C. We still would have gotten, so we have to work out the C now. All right, because yeah, there was an error right there. So I hope everybody see that. Yeah, that was just an error, guys, on my part. So I accept that. That's fine. Because when I work, I saw that something went wrong. So that is over 12 that we're looking at. And all right, so all right. So let me change this. So right here, let's double look. So doing this part, 3 was already there and the 4 comes down, make it 12. Fine. I'm using a different constant. I'm going to use a constant M because we, in the same situation, we have a constant C already, which is 0. So I'm trying this. So let's try to see now what we'll get. We're still going to get K 0 as well. So M is 0. If I should substitute these to say S is equal to this. So let me just do over this. The displacement was 0, same way. The time was 0, just the same, over 12. So M is still 0. So we're still getting M as 0. So the function now was t to the 4th over 12. And that was the part that yes, over 12. That was the part that I felt something went wrong. All right, good. So what we're going to do now is just drop in the values now and then quickly write out. All right, so we could find the distance here and subtract them. So when t is equal to 2, then s is equal to 2. I'm just working it this way to say that over that. That is what? 16 over 12, right? 16 over 12. All right, 4 into that, 4 over 3. All right, 4 over 3, yeah. Okay, 1 and 1/3. All right, good. 1 and 1/3. Let me write it better. 1 and 1/3. All right. All right, we're getting somewhere now. 1 and 1/3. All right, good. 1 and 1/3. Fine. And then when t is 0, yeah, when t equals 0, let me fix that. T equal 0. S is going to equal to 0 to the 4th over 12. So this is 0 already. This gives us 0. So that means that the answer then, the displacement is equal to 1 and 1/3 units. All right, good. All right, 1 and 1/3 units right there. All right. All right, so we're good with that. This is good now. This is good. This is perfect. This is perfect. 1/3 and then the 4 goes underneath to become 1/12, which is over 12. All right, good, good, good. All right. All right, I think this was the last question. So I'm going to have to go back up. All right, hold on. So let me go back up. The board freeze a little bit. Give me a minute. 1 minute. All right, all right, there it is. That was the last question on the board. So we skipped We have like about 10 minutes. I'm going to jump on this one, this probability one let's do this. Let's do this statistics, the probability question right now, quickly. All right, let's jump on that. All right. It says here that our working must be clearly shown. 2 fair tetrahedron dice with faces numbered 1, 2, 3, 4 are rolled. So they roll 2 dice, right? So they roll 2 dice, as you could see right there. So the question says, the numbers obtained on the turn down faces of each die are noted. Create a sample space. All right, listing of all the possibilities. So the tetrahedron dies have 1, 2, 3, 4 on them. We want to create a sample space. So in creating a sample space, we have to rule up a quick thing here. Hold on, quick thing there. We probably have die 1 and we have die 2. The numbers are as follows: 1, 2, 3, 4. Okay, I could space out a little bit more then, since it's 4. All right. 1, 2, 3, 4, and we'd have 1, 2, 3, 4. Because this 4 faces the die has. All right. And then we're going to create all the possibilities if those 2 dice are thrown. Now let's go down. Let's work with this die here. So if I'm looking at this die here, we'll have 1, but it could come with a 1 from the other die. This is die 2. I could get a 2 that still could come with a 1. I could get a 3 that could come with a 1. I could get a 4 that could come with a 1 from the other die. So you could see we are having that. A 1 with a 1, a 2 with a 1, a 3 with a 1, a 4 with a 1. Then now, if you're really looking at, there's a pattern, all right? There could be a 1 here with a 2, a 1 with a 3, a 1 with a 4. So it's up to you how you want to represent this. We could have a 2 with a 2, a 2 with a 3, a 2 with a 4, a 3 with a 2, a 3 with a 3, a 3 with a 4 with a 2, because we had 4 with a 1 already, a 4 with a 3, and a 4 with a 4. So we're saying these are the possible things that could have occurred. 1, 2, 3, 4, 1, 2, 3, 4. We have 16 possibilities. 16. So our sample space is 16. Our sample space is 16. There. Now, that's it. So understanding that, listen, we have 2 dice throwing here. Here is 1. Here's the other one. And these are the possible combination if you should throw them. At any given time, it's going to be one of these. All right, so that's our sample space. I trust that everybody understand that. So what we're looking at now is, they did say use your sample space. So, I mean, there are 2 ways you can work out these. I'm just going to use the sample space because it says use your sample space table created, or otherwise. You don't have to go or otherwise, but in the interest of time, I'm just going to run with it. We have 5 minutes to cut. It says determine the probability of obtaining a 4. So the focus is going to be on a 4 on both die. We could go and look at it. We could go and look, and this is why they said use your sample space. Look, a 4 on both die. It's obviously right here. This is the only one. So it is 1 out of 16 chances for us to get a 4 on both dies. So when you create your sample space, the work actually becomes easier, right? So this answer is definitely 116. I could have worked it another way. I could have said 4 on one die is 1/4. And I could get a 4, which means I'm going to multiply a 4 on the other die. That's another 1/4, and we get 116. But as I said to you, if you have your sample space, you don't have to employ any working out. Just go and look. Let's look at the next question. At least 1 die. So you have to read back. To obtain a 4 on at least 1 die. Oh, obtain a 4 on at least 1 die. At least mean 1 or more. You know? So that means we're going to have to identify all the 4s. So we have 4 here, 4 here, 4 here, 4 there, 4 there, 4 there, 4 there. So when you check this off, you get 1, 2, 3, 4, 5, 6, 7 at least, because at least mean 1 or more based on the context. It's at least 1. So it's 1 or more. So the 2 is in that category. So it's 1. So we're talking about 7 out of 16 because we had 7 times that 4 could come out of a total of 16. So the second response would have been 7 out of 16. I could work it out another way, but in the interest of time, I'll just take it from the table. 7 out of 16. All right. On exactly 1 die. No, you hear that? On exactly 1 die. If I go back to my sample space, I want to see 4 on exactly 1 die, which means that this is not a part of the game. This is not a part of the game anymore because they want it on only 1 die, exactly 1. So we're talking about having a total of 6 responses. 1, 2, 3, 4, 5, 6. 6 out of 16. You could break it down and get 3 out of 8. All right, so the breaking down of it is not even important now because they never said. So it is 6 out of the 16, or you cancel, you get 3 out of 8. So we're reading from the sample space, picking up the answers very straight. And the reason why I'm saying they don't need any hard working, look at those marks. They're just giving you some marks where you can just easily pick up the things from and you go. Let's go to the next question. The next question says, show that obtaining a 4 on both die are independent. All right. Show that obtaining a 4 on both die would be independent. Well, you can you could drop in a set thing here to show that we have die 1 and you have die 2. And when you have here, this is when you get a 4 on both dice. So this part is when we have 4 on both. But you could get a 4 here alone. And so we're talking about having a 4 on die 1 only. So you could say that it is very independent. It's not depending on anything right now. We could get, so we're talking about this section. We could get a 4 on die 1 only. Yeah? Yeah. Right there. Could get a 4 there. Just, I mean, I throw it and I just get a 4 on die 1. And that does not affect the fact that I could throw it and just get a 4 on die 2 only too. So I could get a 4 on die 2 only as well. So you could see that we could get the 4s in 3 different segments. We can get them on the 2 dice, or we could get it on 1 only, as well as we could get it on 2 only. So they're operating independently. Yeah. Yep. That's one. But there's another formula that you can use to show independence. When 2 things are independent, their intersection. All right, let us say we have A versus B, right? So the probability of A intersect B is going to equal to the probability of A times the probability of B. When they are independent, these 2 vibes, like if you find this and then work out these, you'll get the same answer. The moment you can prove that, this is a statement that you can make, that when 2 events A and B are independent, the probability of A intersect B is equal to the probability of A times the probability of B. If you do that and get the same number on either side, on both sides, then you are doing this in another way. This is okay to show. And then you could show this like die 1, die 2. When they intersect, we get 116. And you could check this. If I get the probability of I get 1/4 to get a 4 and A. I get 1/4 to get a 4 and that. And then look for yourself. 116 equal to 116. They are independent as well. Because this is how you can prove independence. Independence, right? You could do this. When two events are independent, you can relate to it this way. And they like to ask it. So I'm just saying, remember this. Remember that. All right, it's after 9. I'm going to allow you to get some sleep. I know you have exam ahead. Sorry, we couldn't have done more because there's a lot of things to do in terms of between the topics that are coming. You'll find a lot of little things, but we did a number of things here. I trust that you will have a good time tomorrow in your exams, and see you guys. So I wish you all the best. Take care.